Alright, so this video is going to be about evaluating rational exponents and nth roots. So maybe you've never seen an exponent before as a fraction, so maybe something like 4 raised to the 1/2 power, or 8 raised to the 1/3, or 32 to the 1/5. If you were to put all those into your calculator, those actually would come out to be actually the same number. So you would have 4 to the 1/2 would end up being 2, 8 to the 1/3 would end up being 2, and 32 to the 1/5 would also end up being 2. And the question is, well, why is that? Well, when you have the 1/2 power, that's the same thing as a square root. So the square root of 4 is 2. And then if you have the 1/3 power, then this bottom number, the denominator, is 3. That changes what we call the index. So you'd have the cube root of 8. And I'll talk about how that equals 2. And then if you look at this fraction, the bottom number is 5. The denominator is 5. So that would be the 5th root of 32. And that also is 2. So how do you get those answers and how do you work through those problems? You kind of go back and forth between using the exponents and using radicals. And so rational exponents are a fancy word for fractions as exponents, and nth roots are fancy words for using roots that have different indexes, is what we call them. So let me give you this. Oh, that's hard to see. Let's go with, right, a raised to the 1 over n. N is what we call the index. So if you had a to the 1 over 2, that's the same as a square root, because the index is 2. So you'd have the square root of a to the 1/3 will be what we call a cube root. Whoops. Because the index is 3. And then a to the 1/4 and so on. You could keep going, would be the 4th root, is how you would say it. And in each one, except the square root we write like that. Cube root, we actually write the index, and it's a small little 3 right there in that little kind of crack there in the little corner. And then the 4th root, you would put a little 4 there as the index. And so how do you simplify or evaluate an nth root? It's actually not too bad. If you can do this one, like the square root of 20, then you can do any nth root. So you would have the square root of 20, you'd break it down into 4 and 5. And then you'd break it down into 2 and 2. And you'd circle the pair of 2's because the index is 2 if you look over there, right? And you're always looking for 2 of the same when you're doing a square root. So we'd say the answer is 2 square root of 5. So now let me go back to the cube root of 8. So when I break 8 down, it'd be 4 and 2. And then that'd be 2 and 2. And so the index tells me the size of my group. The index in this problem is 3. So I'm looking for a group of 3 of the same number. Well, I've got it. And so the index tells me the group, and the group is 3, and I have three 2's, and so the cube root of 8 is just 2. So what happens if it doesn't come out evenly? So let's take a look at that. So for example, let's do this one. Let's go ahead and do 32 to the 1/4. So I write it as a radical. It'd be the 4th root of 32. Then I'd break it down. And so it'd be 8 and 4. Then 2 and 2. Then 4 and 2. And then 2 and 2. The index here tells me I need groups of 4. So I'm going to circle 4 of these 2's. and they have to be the same number. So 4 2's, which means this group puts a 2 on the outside of the radical. That's representing my group of 4 2's. I still use the fourth root. And then this 2 right here that's not in the group remains on the inside. So the fourth root of 32 is 2 fourth root of 2. We'll do one more. So if I had, and this is kind of interesting, it'll work. If I had the cube root of negative 16. So the cube root of negative 16 actually will work really well. And the reason it'll work is because you can actually break this up. So what multiplies to negative 16? It would be negative 8 and 2. And if you think about negative 8 will actually break up into negative 2 times negative 2 times negative 2. And so you'll actually have 3 negative 2's that will make your group of 3. And so you'll have a group of 3 negative 2's. So that will go on the outside. And the positive 2 will remain on the inside. So the neat thing about cube roots is you can actually cube root a negative. And so then the final thing would be is after we do that, there's one more thing you can kind of do with nth roots and exponents. And so it would look like this. What happens if you have a fraction as your exponent where the numerator is not 1? So a to the m over n. So for example, it would be something like 8 to the 2/3. So how would you do that? Well, there's two ways that you can write it. You can write it as the nth root of a and then raised to the m on the outside, or you can write it as, whoops, didn't need that part. You just write it as the nth root of a to the m, like that. So 8 to the 2/3 can be written as the cube root of 8 and then squared, or can be written as the cube root and then 8 squared on the inside. 8 squared becomes 64, and that's a bigger number, so it might be easier to work with a smaller number, and we already know the cube root of 8. The cube root of 8 is 2, and then 2 squared is 4. And so that's how you would evaluate it. And so I'll do one more, just so that you kind of can see the idea, and I'll leave that in the problem. So what if I said it was negative 32 and then to the 3/5. So we could write it this way. You would write it as the fifth root of negative 32 and then raised to the third. So can I do the fifth root of a negative? The answer is yes, because it's an odd index, and so it just means your answer is going to be negative. So if you think about what we had on the very front, I said that the fifth root of 32 was positive 2. So the fifth root of negative 32, if you break it down, it would have 5 negative 2's. And so the fifth root of negative 32 is negative 2 to the third power. And so negative 2 times negative 2 times negative 2 is negative 8. And that'd be your answer. And so that's how you evaluate when an exponent has a fraction in it. It turns into a radical, an nth root, and then we can simplify by breaking it down and get it done that way. All right, have a great day.